So this is Andrej Karpathy. He was a founding team member of OpenAI and also the former Tesla autopilot leader. I really enjoy listening to this person talk because number one, he's extremely knowledgeable, smart, and very, very deep into AI research, AI development. But also, he is able to present a lot of these advanced concepts in a very easy to understand manner. He recently did an interview on the No Priors podcast, an excellent show to subscribe to if you haven't already. In this video, let's take a look at some of the things that really jumped out to me about this interview. Back in 2017, Google published this research paper called Attention is All You Need. A lot of the authors of that paper has since left to found their own AI startup companies. This paper presented the Transformer, a neural network architecture. That was kind of a big deal. In this next clip, Andrej is asked if we're going to hit some roadblock in AI development, whether this is for robots or AI in general. Here's what he has to say, and pay attention to what he says about the Transformer.
I don't know that there's like any individual impediments that I'm like really familiar with. I just think it's a lot of grunt work. A lot of like the tools are available. And Transformers are this beautiful like blob of tissue. You can just get just arbitrary tasks, and you just need the data. You need to put it in the right form. You need to train it. You need to experiment with it. You need to deploy it, iterate on it. That's just a lot of grunt work. I don't know that I have a single individual thing that is like holding us back technically.
Where are we in the state of large blob research?
Large blob research?
Yeah.
We're in a really good state. So I think, I'm not sure if it's fully appreciated, but like the Transformer is like much more amazing. It's not just another neural net. It's like an amazing neural net, extremely general. So for example, when people talk about the scaling laws in neural networks, the scaling laws are actually to a large extent
He's talking about the scaling laws, this idea that the more compute we throw at it, the better it gets. I think OpenAI's Sora, the technical paper, kind of illustrated this, I think, in a very good way. So on the left, this monstrosity you see here is kind of like the default that they've used. They increase it fourfold, and all of a sudden, you can kind of begin to recognize there's a dog, it's wearing a hat, there's an owner. And at 32x the compute versus, the base compute, right? If we increase it 32 times, all of a sudden that looks like high fidelity, high quality video that looks lifelike. It's the same model, the same data, the same prompt. The only thing that changes is we throw more compute resources at it. This has held up so far, and we expect this to continue.
When people talk about the scaling laws in neural networks, the scaling laws are actually to a large extent a property of the Transformer. Before the Transformer, people were playing with LSTMs and stacking them, etc. You don't actually get like clean scaling laws, and this thing doesn't actually train and doesn't actually work. It's the Transformer that was the first thing that actually just kind of like scales, and you get scaling laws and everything makes sense. So it's just like general purpose training computer. I think of it as kind of a computer, but it's like a differentiable computer. And you can just give it inputs and outputs and billions of it, and you can train with backpropagation. It actually kind of like arranges itself into a thing that does the task. And so I think it's actually kind of like a magical thing that we've stumbled on in the algorithm space. And I think there's a few individual innovations that went into it. So you have the residual connections. That was a piece that existed. You have the layer normalizations that needs to slot in. You have the attention block. You have the lack of these like saturating nonlinearities like 10Hs and so on. Those are not present in the Transformer because they kill gradient signals. So there's 4 or 5 innovations that all existed and were put together into this Transformer. And that's what Google did with their paper. And this thing actually trains. And suddenly you get scaling laws, and suddenly you have like this piece of tissue that just trains to a very large extent. And so it was a major unlock.
You feel like we are not near the limit of that unlock, right? Because I think there is a discussion of course, like the data wall and how expensive another generation of scale would be. Like, how do you think about that?
So that's where you start to get into, like, I don't think that the neural network architecture is like holding us back fundamentally anymore. It's like not the bottleneck. Whereas I think before Transformer, it was a bottleneck, but now it's not the bottleneck. So now we're talking a lot more about what is the loss function? What is the data set? We're talking a lot more about those, and those have become the bottlenecks almost. It's not the general piece of tissue that reconfigures based on whatever you want it to be. And so that's where I think a lot of the activity has moved. And that's why a lot of the companies and so on who are applying these technologies, like they're not thinking about the Transformer much. They're not thinking about the architecture. The Llama release, like the Transformer hasn't changed that much. We've added the rope relative positional encodings. That's like the major change. Everything else doesn't really matter too much. It's like plus 3% on a small few things. But really it's like rope is the only thing that's slotted in. And that's the Transformer as it has changed since the last 5 years or so. So there hasn't been that much innovation on that. Everyone just takes it for granted. Let's train it, etc. And then everyone's just innovating on the data set mostly and the loss function details. So that's where all the activity has gone to.
Next, they talk about synthetic data. The question being, are we going to run out of real human-written data on the internet? Is the internet the highest form, the highest quality of data that we have available? Last year, Microsoft released a paper called Orca 2, where they took the reasoning out of GPT-4. So they would ask GPT-4 a question like, they would give a problem like put these different sentences in chronological order, so what order they go into, and walk us through your reasoning step by step. So GPT-4 would output the correct answer and provide its reasoning. They took that data, that synthetic data that was produced by the large language model GPT-4, and they used it to train a much, much smaller model called Orca 2. That was the training data for it. And that model got really good at doing that thing. It would do that thing as well as models 10 times its size.
Right. But what about the argument, like in that domain, that was easier when we were taking internet data? And we're out of internet data. And so the questions are really around like synthetic data or more expensive data collection.
So I think that's a good point. So that's where a lot of the activity is now in the LLMs. So the internet data is like not the data you want for your transformer. It's like a nearest neighbor that actually gets you really far, surprisingly. But the internet data is a bunch of internet web pages, right? It's just like what you want is the inner thought monologue of your brain.
Yep.
That's the ideal
trajectories
data.
In your brain.
The trajectories in your brain as you're doing problem solving. If we had a billion of that, like AGI is here, roughly speaking. I mean, to a very large extent. And we just don't have that. So where a lot of activity is now, I think, is with the internet data that actually gets you like really close, because it just so happens that internet has enough of reasoning traces in it and a bunch of knowledge, and the transformer just makes it work. Okay. So I think a lot of activity now is around refactoring the data set into these inner monologue formats. And I think there's a ton of synthetic data generation that's helpful for that. So what's interesting about that also is like the extent to which the current models are helping us create the next generation of models.
And we're seeing this more and more. So recently, OpenAI has stated that some of the newer models will be used to train smaller models, the Strawberry Orion models. I kind of tend to think of it as in Aliens, you had the hive queen, right? That sat in this chamber and just produced the eggs, and those became the little drones that went out and did its bidding. And I think that's kind of like the model or the analogy for future AI models. You have the large, smart, expensive, unwieldy model producing the synthetic data. That synthetic data is used to train the actual models that are going to be doing the thing that you want them to do, that's interfacing with, the end user, etc. So I guess that would make synthetic data the royal jelly in this analogy. I like it.
How much do you think synthetic data is, or how far does that get us, right? Because to your point on each model helps you train the subsequent model better, or at least create tools for it, data labeling, whatever, maybe part of it is synthetic data. How important do you think the synthetic data piece is? Because what they say,
I think that's the only way we can.
That did not get picked up in the transcript. And also they're kind of talking over each other for a second. I believe Andrej saying it's incredibly important.
How important do you think the synthetic data piece is? Because when I
It's
talk to people, they say,
I think it's the only way we can make progress is we have to make it work. I think with synthetic data, just have to be careful because these models are silently collapsed is like one of the major issues. So if you go to ChatGPT and you ask it to give you a joke, you'll notice that it only knows like 3 jokes. That's like it gives you like 1 joke, I think most of the time. And sometimes it gives you like 3 jokes. And it's because the models are collapsed and it's silent. So when you're looking at any single individual output, you're just seeing a single example. But when you actually look at the distribution, you'll notice there's not a very diverse distribution. It's silently collapsed. When you're doing synthetic data generation, this is a problem because you actually really want that entropy. You want the diversity and the richness in your data set. Otherwise, you're getting collapsed data sets. And you can't see it when you look at any individual example. But the distribution has lost a ton of richness. And so it silently gets worse. And so that's why you have to be very careful and you have to make sure that you maintain your entropy in your data set. And there's a ton of techniques for that. As an example, someone released this persona data set as an example. The persona data set is a data set of 1 billion personalities, like humans, like backgrounds.
Yes, I saw this. Yeah,
I'm a teacher or I'm an artist. I live here. I do this, etc.
So I believe this is what he's referring to. Persona Hub, redefining synthetic data generation with 1 billion unique perspectives. Looks like it's coming out of the Tencent AI lab in Seattle, and they're addressing the critical need for diversity in artificial intelligence data. It has a massive repository of 1 billion unique personas. There's a post that kind of visualizes kind of what they're talking about. So as you can see, you can have where you have your billion personas from personas hubs, for example, a moving company driver, a chemical kinetics researcher, etc. And so if you need a math problem, each one can be sort of made to have more diversity, more richness, etc. by kind of taking these one of these billion personas into account. Same thing with a logical reasoning problem or a user prompt to an LLM, for example.
The persona dataset is a dataset of 1 billion personalities, like humans, like backgrounds.
Yes, I saw this. Yeah,
I'm a teacher or I'm an artist. I live here. I do this, etc. And it's like little paragraphs of like fictitious human background. And what you do when you do synthetic data generation is not only like, oh, complete this task and do it in this way, but also imagine you're describing it to this person and you put in this information and now you're forcing it to explore more of the space and you're getting some entropy. So I think you have to be just very careful to inject the entropy, maintain the distribution. And that's the hard part that I think maybe people aren't like sufficiently appreciating as much in general. So I think basically synthetic data, absolutely the future. We're not going to run out of data is my impression. I just think you have to be careful.
One of the interesting things about neural nets is a lot of our progress in this area, we're kind of mimicking nature or mimicking the human brain. So one of the conversations that takes place is, for example, at what point will computer neural nets reach the same sort of level as the human brain in terms of the number of connections, etc.
What do you think we are learning now about human cognition from this research?
I don't know if we're
One
learning
could
much about it.
argue that like figuring out the shape of reasoning traces we want, for example, is instructive to actually understanding how the brain works.
I would be careful with those analogies, but in general, I do think that it's a very different kind of thing. But I do think that there are some analogies you can draw. So as an example, I think transformers are actually better than the human brain in a bunch of ways. I think they're actually a lot more efficient system. And the reason they don't work as good as the human brain is mostly a data issue, roughly speaking, is the first order approximation, I would say. And actually, like as an example, like transformer memorizing sequences is so much better than humans. Like if you give it a sequence and you do a single forward backward pass in that sequence, if you give it the first few elements, it will complete the rest of the sequence. It memorized that sequence. And it's so good at it. If you gave a human a single presentation of a sequence, there's no way that you can remember that. And so the transformers actually, I do think there's a good chance that the gradient based optimization, the forward backward update that we do all the time for training neural nets, is actually more efficient than the brain in some ways. And these models are better. They're just not yet ready to shine. But in a bunch of cognitive sort of aspects, I think they might come out.
With the right inputs, they will be better.
That's generically true of computers, though, for all sorts of applications, right?
And I think
to your point.
Yeah, exactly. And I think human brains just have a lot of constraints. You know, the working memory is very small. I think transformers have a lot bigger working memory and will continue to be the case. They're much more efficient learners. The human brains function under all kinds of constraints. It's not obvious that the human brain uses backpropagation, right? It's not obvious how that would work. It's a very stochastic sort of dynamic system. It has all these constraints it works under, so ambient conditions, etc. So I do think that what we have is actually potentially better than the brain, and it's just not there yet.
Interesting thing to think about. If we've created something that's sort of better than the human brain, more efficient, we just need to figure out the right inputs to kind of like really take advantage of it. Similar to how back in the days we figured out, let's say the steam engine or some other ways of propulsion that were, potentially far superior to something being moved by muscle, by ATP and muscle contraction, etc. And now you might hear a piece of machinery being referred to as having roughly, 20,000 horsepower. It's almost this absurd comparison, but what if in 10, 20, 30 years, we'll have some neural net or some software, some computer that would be equivalent to 20,000 human brains. And the basic infrastructure already exists today. We just need to figure out how to sort of make it work. And of course, if there exists a chip that's 20,000 times smarter, somehow better at various cognitive tasks than your brain is, wouldn't you want that thing augmenting your brain?
How do you think about human augmentation with different AI systems over time? Do you think that's a likely direction? Do you think that's unlikely?
Augmentation
of people with AI models.
Oh, of course. I mean, but in what sense maybe? I think in general, absolutely.
Because there's the abstract version of it you're using as a tool. That's the external version. There's the, the merger scenario, a lot of people end up talking about.
Yeah. I mean, we're already kind of merging. The thing is like, there's the IO bottleneck.
Sure.
But for the most part, at your fingertips, if you have any of these models.
Yeah, but that's a little bit different because people have been making that argument for, I think, 40, 50 years where technological tools are just extension of human capabilities, right?
Yeah, the computer is the bicycle for human.
Correct. So, but there's
a
subset of the AI community that thinks that, for example, the way that we subsume some potential conflict with future AI or something else would be through some form of...
like the Neuralink pitch, etc.
Yeah, I was about to say, the subset of the community. I mean, that's, I guess, personified in this case by Elon Musk. I mean, I feel like at this point, he said that enough times to where that's his stance that something like this could potentially be a big driver in AI safety, right? If AI, if you imagine this super intelligence, right? If it's a thing that's separate from us, well, that might be bad for us, right? But if it's something that we're a part of, we're coexisting, it's a kind of like the gut bacteria that we live with, right? It's sort of this thing we coexist with. One needs the other, then maybe humans might be a lot safer. It would be a big step towards AI safety.
Exactly.
I don't know what this merger looks like yet, but I can definitely see that you want to decrease the IO to tool use. And I see this as kind of like an exocortex we're building on top of our neocortex, right? And it's just the next layer. And it just turns out to be in the cloud, etc. But it is the next layer of the brain.
Elon Musk, in one of the interviews, actually with Lex Friedman, gave a very interesting way of looking at it. If you think about sort of how our brain functions, we also have kind of like the different layers of it, right? So we have the kind of the older base layers, right? The procreate, eat, survive, etc. We have kind of the newer, smarter portions of the brain, right? The ones that can do math or design spaceships, etc. The ones that can plan ahead. So what if you think of AI, once it gets sufficiently advanced, as sort of like the next layer? We humans, in a lot of ways, are slaves to our more primitive drives, right? We want to eat and survive. So we get a degree, we get a job, we go to work every day and try to make money so that we can afford to eat and have kids and whatnot. People starve themselves and lift weights and run on treadmills to be able to have a chance to procreate. Or, at least engage in the act of. So could we see some sort of a very advanced AIs kind of being like that next level? Like we, the human, we're still that deeper thing that just wants stuff, right? I'm bored, entertain me. I'm hungry, get me food, etc. But kind of like at the very top of our brain, how did Andrej put it? The exocortex, right? This kind of like next layer that allows us to have this incredible intelligence that's able to achieve those kind of base desires, right? Because if that super intelligence has desires of its own, that's when it gets a little bit iffy. That's when it gets a little bit scary, perhaps. But if it's really good at figuring out how to meet its goal, but we, the humans, are the thing that sets the goals, well, certainly that's a little bit less scary.
Yeah, Accelerando, a book from the early 2000s, has a version of this where basically everything is substantiated in a set of goggles that are computationally attached to your brain that you wear. And then if you lose them, you must feel like you're losing a part of your persona or memory.
I think that's very likely, yeah. And today the phone is already almost that. And I think it's going to get worse. When you put your techno stuff away from you, you're just naked human in nature.
You lose part of your intelligence.
No,
it's very anxiety inducing.
A very simple example of that is just maps, right? So a lot of people now have noticed can't actually navigate their city very well anymore because they're always using turn-by-turn direction.
And if we have this, for example, like universal translator, which I don't think is too far away, like you'll lose the ability to speak to people who don't speak English if you just put your stuff away.
I'm very comfortable repurposing that part of my brain to do further research.
I don't know if you saw the video of like the kid that's has a magazine and is trying to like swipe on the magazine.
Yes, yeah.
What's fascinating to me about it is like this kid doesn't understand what comes with nature and what's technologically on top of the nature.
Yeah.
Because it's made so transparent. And I think this might look similar where people will just start assuming the tools. And then when you take them away, you realize like, I guess like people don't know what's technology and what's not. If you're wearing this thing that's always translating everyone or like doing stuff like that for you, then maybe people like lose the
basic cognitive abilities may not exist.
Yeah,
I think it's
like by nature. Or like,
We're going to specialize.
You can't understand people who speak Spanish. Like what the hell?
And next we dive into open source versus, closed source, maybe some sort of an oligopoly of tech players that control access to AI. What's better? Is it not your weights, not your brain? Or is it, keep it locked behind locked doors and make sure that the bad guys don't get it? What's the correct approach there?
How do you think like the current market structure of what's happening in LLM research? There's a small number of large labs that actually have a shot at the next generation progressing training. Like, how does that translate to what people have access to in the future?
So what you were kind of alluding to maybe is the state of the ecosystem, right? So we have kind of like an oligopoly of a few closed platforms, and then we have an open platform that is kind of like behind, so like Metalama, et cetera. And this is kind of like mirroring the open source kind of ecosystem. I do think that when this stuff when we start to think of it as like an exocortex, so there's a saying in crypto, which is like not your keys, not your keys.
Yeah.
Like, is it the case that if it's like not your weights, not your brain?
That's interesting because a company is effectively controlling your exocortex and therefore
it starts to feel kind of invasive. If this is my exocortex,
I think people care much more about ownership. Yeah.
Like you realize you're renting your brain. Like it seems strange to rent your brain.
The thought experiment is like, are you willing to give up ownership and control to rent a better brain? Because I am. Yeah.
So I think that's the trade-off. I think we'll see how that works, but maybe it's possible to like by default use the closed versions because they're amazing, but you have a fallback in various scenarios. And I think that's kind of like the way things are shaping up today even, right? Like when APIs go down on some of the closed source providers, people start to implement fallbacks to like the open ecosystems, for example, that they fully control and they feel empowered by that, right? So maybe that's just the extension of what it will look like for the brain is you fall back on the open source stuff. Should anything happen, but most of the time you actually...
So it's quite important that the open source stuff continues to progress.
I think so, 100%. Yes. And this is not like an obvious point or something that people maybe agree on right now, but I think 100%.
I guess one thing I've been wondering about a little bit is what is the smallest performant model that you can get to in some sense, either in parameter size or however you want to think about it? And so I'm a little bit curious about your view, because you've thought a lot about the distillation, small models,
I think it can be surprisingly small. And I do think that the current models are wasting a ton of capacity remembering stuff that doesn't matter. Like they remember SHA hashes, they remember like the ancient...
Because the data set is not curated the best.
Yeah, exactly. Yeah. And I think this will go away. And I think we just need to get to the cognitive core. And I think the cognitive core can be extremely small. And it's just this thing that thinks. And if it needs to look up information, it knows how to use different tools.
Is that like 3 billion parameters? Is that 20 billion parameters?
I think even a billion suffices.
That's very interesting. So you could potentially have a tiny model, a billion parameter model that just thinks. It's the core cognitive piece, and then whatever information it needs, it looks up because, of course, that information is readily available. It doesn't have to memorize it. I mean, that was kind of their point about people forgetting how to, navigate their town because of maps. We no longer remember phone numbers because it's all in our phone. If you're able to store and rapidly recall whatever information you need, you're not going to memorize it. So why should these large language models memorize all this stuff when you have a lightning speed access to the internet, to all the databases, etc.?
We'll probably get to that point, and the models can be very, very small. And I think the reason they can be very small is fundamentally, I think, just like distillation works. It may be like the only thing I would say. Distillation works like surprisingly well. Distillation is where you get a really big model or a huge amount of compute or something like that, supervising a very small model. And you can actually stuff a lot of capability into a very small.
Is there some sort of like mathematical representation of that, or some information theoretical like formulation of that? Because it almost feels like you should be able to calculate that now in terms of what's the...
Maybe like one way to think about it is like, we go back to like the internet data set, which is what we're working with. The internet is like 0.001% cognition, and like 99.99% of like information is just like,
Yeah.
And I think most of it is not useful to the thinking part. And it's like,
yeah. I guess maybe another way to frame the question is like, is there a mathematical representation of cognitive capability relative to model size? Or how do you capture cognition in terms of, here's the min or max relative to what you're trying to accomplish? And maybe there's no good way to represent that. So I think maybe 1 billion parameters gets you sort of like a good cognitive core.
I think probably right. I think even 1 billion is too much. I don't know, but we'll see.
It's very exciting, given if you think about, it's a question of like on an edge device versus on the cloud, but.
And also this raw cost of using the model and everything. Yeah.
Yeah, that's one interesting thing to think about. What if the cognitive part of the model could be really good, really fast, really small, really cheap to use? I mean, basically any device that you use would have a genius sitting in it, right? Your thermostat, your garage door, your speakers, your car stereo, the lights inside your house. It's interesting to think about what happens if there's a massive, powerful brain that's charged with just optimizing the basic, most everyday things like the lights in your house. It's just able to create the best aesthetics at the most efficient electricity use, and just whatever metrics you want to use, it creates the best lighting environment imaginable. And every single thing is like that, from the very, very basic to every piece of global transport, the supply chain of any hospital procedure. That would be a very different world.
That's very exciting.
Right. But at less than 1 billion parameters, I have my exocortex on a local device as well.
Yeah. And then probably it's not a single model, right? Like it's interesting to me to think about what this will actually play out like, because I do think you want to benefit from parallelization. You don't want to have a sequential process. You want to have a parallel process. And I think companies to some extent are also kind of like parallelization of work. But there's a hierarchy in a company because that's one way to, you have the information processing and the reductions that need to happen within an organization for information. So I think we'll probably end up with companies of LLMs. I think it's not unlikely to me that you have models of different capabilities specialized to various unique domains. Maybe there's a programmer, etc. And it will actually start to resemble companies to a very large extent. So the programmer and the program manager and, similar kinds of roles of LLMs working in parallel and coming together and orchestrating computation on your behalf. So maybe it's not correct to think about it. It's more like a swarm.
It's like an ecosystem. It's like a biological ecosystem where you have specialized roles and niches.
And I think it will start to resemble that.
You have automatic escalation to other parts of the swarm, depending on the difficulty of the problem and the specialization.
And with that, this is the Black Mirror episode that I can't help but think of when we're talking about all of that. I'm not going to spoil it for you, but yeah.
It was like a really brilliant cloud model.
Yeah.
But the workers can be a lot cheaper, maybe even open source models or whatnot.
And my cost function is different from your cost function.
I think she runs her own hedge fund or something like that. So is that like a diss? My AI cost function is different from your AI cost function. Is that a flex, I wonder?
You've always been an educator. Like, why do this?
And next, of course, they talk about the very new Andrej Karpathy project that he's starting. He is getting into educating people on how to build their own neural nets, their own large language models. There's one person that's trying to get him on their team, though. I think there was a tweet somewhere with Ilya asking Andrej Karpathy to join him on his ASI mission, or rather SSI, Safe Superintelligence. Can't find it right now. But whatever the case, it's interesting to realize that somebody like Andrej Karpathy probably has a lot of doors open to him. He could easily get jobs at Google or Facebook or Elon Musk's XAI or Ilya's SSI, or probably anywhere else really, but he chooses to do his own thing and he chooses to educate the world on this new technology that's now emerging into the world.
You left OpenAI, you're working on education, you've always been an educator. Like, why do this?
I would start with, I've always been an educator and I love learning and I love teaching. And so it's kind of just like a space that I've been very passionate about for a long time. And then the other thing is, I think one macro picture that's kind of driving me is, I think there's a lot of activity in like AI. And I think most of it is to kind of like replace or displace people, I would say, is in the theme of like sliding away the people. But I'm always more interested in anything that kind of empowers people. And I feel like I'm kind of on a high level, like team human, and I'm interested in things that AI can do to empower people. And I don't want the future where people are kind of on the side of automation. I want people to be very in an empowered state, and I want them to be amazing, much more amazing than today. And then other aspects that I find very interesting is like, how far can a person go if they have the perfect tutor for all the subjects? And I think people could go really far if they had the perfect curriculum for anything. And I think we see that with, if some rich people maybe have tutors and they do actually go really far. And so I think we can approach that with AI or even like surpass it.
Yes, I think they mentioned a little bit later, the 2 sigma, the Bloom problem. Basically, the idea is that schools are horribly under optimized. We can have, each student can learn at a much better rate. It's 2 standard deviations better. So basically, most students would be A+ students if we tweaked how we approach teaching with just 2 minor tweaks. One is mastery learning, where people go at their own pace, and 2 is one-on-one tutoring. And of course, that's not really feasible, right? Because we want everybody in a classroom kind of on the same schedule, and having one instructor to many students, that's the only way that we can make the economics work. But if you're able to afford tutors, of course, you are learning at a much, much, much better rate. And this is one of the problems where I'm excited about seeing how AI could potentially tackle that issue, because certainly it can be an incredibly effective one-on-one tutor.
And so I think we can approach that with AI or even like surpass it.
Or even like surpass it is what he says.
80s, right? Where one-on-one tutoring, I think, helps people get 1 standard deviation better than
Bloom.
Is it 2? Yeah,
Yeah.
It's the Bloom stuff. Yeah, exactly. There's a lot of really...
Mastery learning improves it 1 standard deviation, and the one-on-one tutoring is the 2nd standard deviation improvement for all students. Here's what that looks like. So this is the standard. So this is kind of like the normal curve, the distribution of students, right? So you got your A+ students here, right? You kind of got your average students here in this majority, like in this, most of them are kind of like right around the average, right? You got your D and F students here, right? So if we add mastery learning instead of whatever the quarter or semester system, right, that improves it 1 standard deviation. All of a sudden, the average student is much higher up. You got that plus individual tutoring, and all of a sudden, most students are here in this kind of like top achievement range.
Interesting precedents on that. How do you actually view that as substantiating through the lens of AI? Or what's the first types of products that will really help with that? Or
Well, see, I'm definitely inspired by aspects of it. So like in practice, what I'm doing is trying to currently build a single course. And I want it to be just like the course you would go to if you want to learn AI. I think the problem with basically is like, I've already taught courses, like I taught 231N at Stanford, and that was the first deep learning class and was pretty successful. But the question is like, how do you actually like really scale these classes? So like, how do you make it so that your target audience is maybe like 8 billion people on Earth? And they're all speaking different languages and they're all different capability levels, etc. So and a single teacher doesn't scale to that audience. And so the question is how to use AI to sort of like do the scaling of a really good teacher. And so the way I'm thinking about it is the teacher is kind of doing a lot of the course creation and the curriculum, because currently at AI capability, I don't think the models are good enough to create a good course. But I think they're good to become the front end to the student and interpret the course to them.
Can you imagine if he creates kind of the prototype for this thing that every other college, university teacher can then use, right? They kind of create the curriculum, the top level, and then they utilize AI to then go out and teach the students one-on-one with tutoring at the student's pace, at whatever level capacity that they have, right? Kind of like meeting their capacity, custom tailored to them. How far away are we from something like this? I'm hopeful that this is going to start ramping up this decade.
And so basically the teacher doesn't go to the people, and the teacher is not the front end anymore. The teacher is on the back end designing the materials in the course, and the AI is the front end, and it can speak all the different languages, and it's kind of like takes you through the course.
Should I think of that as like the TA type experience, or is that not a good analogy here?
That is like one way I'm thinking about it. It's AI TA. I'm mostly thinking of it as like this front end to the student, and it's the thing that's actually interfacing with the student and taking them through the course. And I think that's tractable today, and it just doesn't exist, and I think it can be made really good. And then over time, as the capability increases, you would potentially refactor the setup in various ways. I like to find things where, like the AI capability today and having a good model of it, and I think a lot of companies that maybe don't quite understand intuitively where the capability is today, and then they end up kind of like building things that are kind of like too ahead of what's available, or maybe not ambitious enough. And so I think I do think that this is kind of a sweet spot of what's possible and also really interesting and exciting. So
I want to go back to something you said that I think is very inspiring, especially coming from like your background and understanding of where exactly we are in research, which is essentially like we do not know what the limits of human performance from a learning perspective are, given much better tooling. And I think there's like a very easy analogy to, we just had the Olympics like a month ago, right? And you know, a runner and it's the very best mile time, or pick any sport today, is much better than it was, putting aside performance enhancing drugs like 10 years ago, just because like you start training earlier, you have a very different program. We have much better scientific understanding. We have technique, we have gear. The fact fact that you believe like we can get much further as humans if we're starting with
100%,
like the tooling and the curriculum is amazing.
Yeah, I think we haven't even scratched like what's possible at all. So I think there's like two dimensions basically to it. Is number one is the globalization dimension of like, I want everyone to have really good education. But the other one is like, how far can a single person go?
Yeah.
I think both of those are very interesting and exciting.
Usually when people talk about one-on-one learning, they talk about the adaptive aspect of it, where you're a challenging person at the level that they're at. Do you think you can do that with AI today, or is that something for the future? And it's more, today it's about reach and multiple languages and globalization.
I think the low-hanging fruit is things like, for example, different languages. Super low-hanging fruit. I think the current models are actually really good at translation, basically, and can target the material and translate it like at the spot. So I think a lot of things are low-hanging fruit. This adaptability to a person's background, I think, is like not at the low-hanging fruit, but I don't think it's like too high up or too much away. But that is something you definitely want, because not everyone is coming in with the same background. And also what's really helpful is like, if you're familiar with some other disciplines in the past, then it's really useful to make analogies to the things you know. And that's extremely powerful in education. So that's definitely a dimension you want to take advantage of. But I think that starts to get to the point where it's like not obvious and needs some work. I think like the easy version of it is not too far, where you can imagine just prompting the model. It's like, oh, hey, I know physics, or I know this. And you probably get something. But I guess what I'm talking about is something that actually works, not something that like you can demo and work sometimes. So I just mean like it actually really works, and in the way a person would.
Yeah. And that's the reason I was asking about adaptability, because also people learn at different rates, or certain things they find challenging that others don't, or vice versa. And so it's a little bit of how do you modulate relative to that context. And I guess you could have some reintroduction of what the person is good or bad at into the model over time as you.
That's the thing with AI. I feel like a lot of these capabilities are just kind of like prompt away. So you always get like demos, but like, do you actually get a product? You know what I mean? So in this sense, I would say the demo is near, but the product is far.
So one thing we were talking about earlier, which I think is really interesting, is sort of lineages. That happens in the research community, where you come from certain labs and everybody gossips about being from each other's labs. I think a very high proportion of Nobel laureates actually used to work in a former Nobel laureate's lab. So there's some propagation of, I don't know if it's culture or knowledge or branding or what. And in an AI education-centric world, how do you maintain lineage, or does it not matter? Or how do you think about those aspects of propagation of network and knowledge?
I don't actually want to live in a world where lineage like matters too much, right? So I'm hoping that AI can help you destroy that structure a little bit. It feels like kind of gatekeeping by some finite, scarce resource, which is like, oh, there's a finite number of people who have this lineage, et cetera. So I feel like it's a little bit of that aspect. So I'm hoping it can destroy that.
I like this guy.
It's definitely one piece, like actual learning, one piece pedigree. Right?
Yeah.
Well, it's also the aggregation of, it's a cluster effect, right? It's like, why is much of the AI community in the Bay Area? Or why is most of the fintech community in New York?
Yeah.
And so I think a lot of it is also just you're clustering really smart people with common interests and beliefs, and then they kind of propagate from that common core, and then they share knowledge in an interesting way. You got to agree a lot of that behavior has shifted online to some extent, particularly for younger people.
I think one aspect of it is kind of like the educational aspect, where like if you're part of a community today, you're getting a ton of education and apprenticeship, et cetera, which is extremely helpful and gets you to a point of empowered state in that area. I think the other piece of it is like the cultural aspect of what you're motivated by and what you want to work on. What does the culture prize, and what do they put on a pedestal, and what do they kind of like worship, basically? So in academic world, for example, is the H index. Everyone cares about the H index, the amount of papers you publish, et cetera. And I was part of that community and I saw that. And I feel like now I've come to different places and there's different idols in all the different communities. And I think that has a massive impact of what people are motivated by and where they get their social status and what actually matters to them.
So I think I'll stop it right there. I definitely covered most, if not everything, that really kind of jumped out at me. I'll leave a link to the interview down below. In the beginning, they talk about robots and self-driving cars, and it's absolutely fascinating. Since we don't talk about that as much on this channel, we didn't cover that here. I really wanted to get into the actual neural nets and the AI and where he thinks this progress is going. So I think that's it for me. This sun is trying to attack me. It's kind of getting annoying because I either have to lean forward or lean back to not have it shine directly in my eyes. But let me know in the comments, would you rent out your brain to get a more powerful brain? Would you pay extra if you could upgrade your cognitive capacity, but you had to kind of maybe rely a little bit more on some big tech company? How would you feel about that? Is it, in fact, not your weights, not your brain? Or do you think if you can get some sort of a cognitive advantage over your fellow people, that you would, in fact, maybe take that risk and go for it? If you made it this far, I appreciate you watching. My name is Wes Roth, and I'll see you next time.